Hello friends! So, after doing my presentation on fluorescent minerals, I remembered that George Gabriel Stokes was able to split apart sunlight and divide that up into its constituent parts, including fluorescence, or ultraviolet. So in that case, I happen to, due to my work with lasers, have a couple of prisms that will split light up into its rainbow parts. So I thought we'd take some highly fluorescent minerals here and go out into the sunlight and try to see if they fluoresce. We got some fluorite, willemite, hackmanite, sodalite, and some scapolite, which are the brightest things I could find because this is going to be outside, so it could be pretty dim, but we can definitely see a color change from ultraviolet. So let's go test it out. Okay, here we are outside. And just to use my fluorescent, just little filtered light, just to see how it's going to look out here, we can still see some color change. Like you can see that scapolite glowing, willemite just a little bit. You can pretty much see the orange. Biggest thing is the fluorite though. So let's take a look. Now I've got this, and I'm going to try to direct some sun or split up beam. It should just end up right beyond the blue end of this. I am not really seeing anything here, because this should all happen just beyond the purple end. Try to spread out the beam here. Maybe we get it closer. I am not seeing anything. Alrighty. Test of my setup is working. Oh, too close. We got a little bit of a rainbow down here. You can see it. Whoops, if I go like this. Hopefully this is going to get us our UV. We shall see though. Okay, alrighty. This looks like the day. We have an 8 UV index at very high here, going off at 1 to 2 o'clock. And it is 1:27. Let's go make some science. Okay. Alrighty, after some research, I found out that these prisms that are made of glass have the tendency to absorb ultraviolet light. So I went online and managed to grab myself a couple of fused silica, as quartz prisms are apparently able to let ultraviolet pass through. So they're tiny because they're very expensive, but I put together this little wire system to hold them in place so that we can take a look. Let's see what we got going on here. Okay, so I'm gonna have to cover this with my hand too. Also waited for a day that was very high on the UV index. Today should be an 8. And let's see if we can make something happen here. Test out this guy first. So I gotta block the sunlight here. Well, that's fun. Okay, that was fun. So now that car alarm is off here, I'm still not really getting a reaction. I mean, maybe a little bit at the top end of this. What do you think? Hard to tell with fluorite because it's blue. Let's try again with hackmanite. I'm not seeing anything. Let me show you with the flashlight, right? Let's see here. See, that's what it would look like if it was actually having a reaction. But I'm not seeing anything here. What about the scapolite? Should be just beyond the edge of the violet. Yeah, I'm not getting nothing. Which gives us 2 potential possibilities here. The one would be that the amount of ultraviolet on an 8 ultraviolet index day is just not enough to make the rocks react. However, just outside you can see this piece is doing the daylight UV reaction. You can see it's kind of purple. So enough is hitting it so it should show purple, or that blue. Oops. But again, no. It is hot out here too. Yeah, I got nothing. The second option here. Ooh, did I see a little bit there? Maybe, I don't know. What do you think, guys? Probably not. Second option is, I think perhaps these eBay fused silica prisms may actually just be glass. So, back to the drawing board.